Welcome to College Algebra. I'm going to try and talk to you a little bit about distance formula and circles. And I think I talked about it a little bit in class today. Let's go ahead and talk about Pythagoras first. Let me make a little right triangle. And Pythagoras says that if this is a right triangle, then there's a relationship between the sides A, B, and C given by a squared plus b squared equals c squared. And that's the source of our distance formula. If you do the same sort of thing, and I'll try to do it a little differently than I did in class, take this guy and copy him. And then flip it. That way I won't have to trouble you with absolute value or anything like that. We will just go straight to the chase. If I have 2 points in the plane, that'll be my second point to the right and above. It doesn't have to be to the right and above, but this makes it nice. Got 2 points, x1, y1, and x2, y2. Well, they happen to be the vertices of a nice right triangle. I can call this A, and I can call this B, and this C. Then again, a squared plus b squared equals c squared, but the distance A is actually this horizontal distance, which is just the difference between x2 and x1. And technically it's the absolute value, but I've set this up so x2 is to the right, therefore bigger. There's x2 minus x1, and again, the second y value minus the first y value tells you how much you've changed in going from the first point to the second point. And so A is just x2 minus x1. We're going to square that, and we're going to square the difference between the y values, y2 minus y1, that in a quantity squared, and that'll be, I'm going to call that d squared. And in the sequel, in a few minutes, we'll call that r squared. Now what I want to do is derive the equation of a circle from this, derive the distance formula from this, and show you some stuff about circles. We should, by the time we're done, we will have completed the square. Now, that's the square, the distance between those 2 points. This distance between the 2 points, C. I'm going to call that D. Heck, I might even label it R at some point in this hour. Okay. Well, what does that tell us D must be? Well, D, just take the square root of both sides. And that's the distance between 2 points in a plane. That also equals R. Well, this segues very nicely into the equation of a circle, but let's just do a quick example. That looks like 3, 2 to me, and this looks like, this point down here looks like minus 2, minus 4. So for this, the distance between those 2 points is just the length of this line segment between those 2 points. D equals the square root of the quantity x2 minus x1. That's 3 minus a minus 2. That's a difference in the x values. We'll square that. Add to that the difference between the y values, 2 minus a minus 4. Square that. And that gives me the square root of 3 plus 2 is 5. 2 plus 4 is 6. Subtracting a negative there is the same as adding. So this looks like 25 plus 36. And that's a square root of 61, I think. 6 and 5 is 11. Carry the 1. Yep. And as far as I know, 61 is a prime number, so I don't think that simplifies any. And the midpoint, I think Julio nailed it for us in class today. Midpoint, just take the average of the x values and take the average of the y values. Add the numbers up and divide by how many numbers there are. In this case, 2 numbers, so we divide by 2. And we're trying to locate a point somewhere along in here. And I know I'm just doing things very rough, but that's really all you should need when doing these things by hand. x1 plus x2 is minus 2 plus 3 divided by 2. And then the average y value is going to be minus 4 plus 2 divided by 2. And so that looks like 1 divided by 2. Minus 4 plus 2 is minus 2. Minus 2 divided by 2 is minus 1. So it looks like we're at 1/2 minus 1. That's right about there. So that should get you to do your homework on this current section of the book. On the midpoint and just in the distance between 2 points. There will be other problems where the radical might need to be simplified. But other than that, this is the nuts and bolts, the bare bones of the distance formula. And now let's talk about circles. The geometric description of a circle is the set of all points equidistant from a fixed point Okay, that fixed point will be the center, and the coordinates for that point, we always just use the letters h for the x-coordinate and k for the y-coordinate. Equidistant, the distances are. Which stands for radius. And what does the statement say? It says that if I let xy on that circle, then two complete sentences here. Then its distance to the point HK in the center is r. This English sentence is an equation, and equations are sentences. Its distance to HK. Here's its distance to that center point. And we're saying that that's r. Square both sides. Squaring the square root just gets rid of the square root. Squaring the r squared, well, you get r squared. And there's your standard equation. And the biggest part of the algebra on this topic is obtaining the standard form of the circle. Of equation of circle of radius r centered at the point HK. So a quick picture of that. Let me put HK there and draw a circle. And I draw perfect circles because I have the right tools to do so. Freehand, my circles aren't very good. Now what I'm saying is, there's my center, and my radius is R, because the distance from any point on that circle to HK is R. Now, I'm going to give you some quick pointers on how to graph these things. And pardon the noise in between, but every time I go to a new page, that's what I need to do. Got a couple nice circles in the homework that I assigned. I want to give one that's a little bit iffy, yeah, on the sketch. But sketch this guy. Quantity x minus 2 quantity squared equals 8 minus the quantity y plus 2 quantity squared. I think you can see the radius jumping out at you. But let's write this in standard form. X minus 2 quantity squared plus the quantity y plus 2 quantity squared equals 8. And so the center is positive 2, negative 2. Y value is negative 2. I'm reading that off the y plus 2 squared. And the r is the square root of 8. 2 into 8 is 4. 2 into 4 is 2. I got a pair of deuces. I can pull one of them out. Ha! 4 divided by 2 is 2. And so that 2 stays inside the radical. That lonely 2 is still under the radical. Okay? Now, I can get as precise on this as I want. I know that the square root of 2 is about 1.41, but it's less than 2, and so 2 times the square root of 2 is bigger than 2 and less than 4. And that's really good enough for government work when we do the sketch. Notice I'm going to draw my circle first, which is just the coolest way to do it. And the center here is 2 comma negative 2. And then I have to go to the right, 2 plus the radius, 2 square root of 2, to get the x-coordinate there. And the height is still minus 2. Now I'm going to go up 2 from the center, so the x value is the same, and it's minus 2 plus 2 square root of 2 there. And go to the left 2, so it's minus, excuse me, it'll be 2 minus 2 square root of 2, 2 square root of 2 units to the left, minus 2 is that antipodal point, and then down here we've got 2 comma minus 2 minus 2 square root of 2. Not being very precise about this, and let's just get a general location for the x and y axis here. I know that 2 minus 2 is below the x-axis. I know that 2 square root of 2 is bigger than 2, so when I add 2 square root of 2 to negative 2, I get something positive. Right? So the x-axis is below this point. That minus 2 plus 2 square root of 2 puts it above the x-axis. And likewise, the y-axis is somewhere between positive 2 and 2 minus 2 square root of 2. This 2 square root of 2 is a little bit bigger than 2, or somewhat bigger than 2, and so your y-axis is somewhere in there. Now what's hinky about what I'm doing is there's some ambiguity there. But that's why they call these sketches, because that little bit there is a little bit sketchy. I don't know if I've got exactly this or exactly this, or if it falls right in there. But as long as I've got that y-axis in between the center and that left point, I'm going to be pretty happy with it. In the future, we might want to solve y equals 0 for x. So that would be something like this equation, which I'm not going to solve today. But you need to solve that equation for x. To really nail where the circle hits the x-axis and exact position of the y-axis. But this is generally a good enough sketch for where we are and what we're trying to accomplish here. I hope that's okay with you. Now the last skill on these concepts is completing the square skill, and that comes up in some of the later exercises. And here's one. Sketch the circle. And that means nail down the center and nail down the 4 corner points like I did on the previous one. So we have x squared plus 8x plus y squared minus 10y equals negative 5. We want to get this into standard form. And that requires, in this problem, completing the square twice. Okay, so let's see, what's half of, I'm just going to clone that line to be a little more transparent in my write-up so you can see where things came from when you're just looking at a printout of this darn thing. 8 divided by 2 equals 4. And don't put an equal sign here, but use an arrow. So 4 squared is what I'm going to add. And so I better add 4 squared to the right. Notice I'm writing it as a 16 on the right hand side. Same deal with the minus 10y. 10 divided by 2. Oh, okay, I'll go ahead and I'll bite minus 10 divided by 2 equals minus 5, and minus 5 squared equals 25. Doggone it. That should go there. That should go there. And I should have some room. There we go. And the trick here, even though that's a minus sign right there, we got to add 25. Minus 5 in parentheses squared is a positive 5 squared. And you try putting a minus there and you'll see it doesn't work. So add that 5 squared to the right in the form of a 25. And now we're ready to write this. Quantity x plus 4 quantity squared plus quantity y minus 5 quantity squared equals 16 plus 20. 36. Oh, how nice. So the center is minus 4, positive 5, and the radius is the square root of 36, which is 6. Okay. Again, same basic technique here, drawing my circle. Find the center. Go to the right 6. Minus 4 plus 6 is 2. Go to the left 6. Minus 4 minus 6 is minus 10. Go up 6 from 5. Go down 6 from 5. Okay. And then throw in your x and y axes. Oops. Something like that. And again, there's some ambiguity. I know that it's going to be closer to the positive 2 than the minus 4, but this y-axis, it might be there, it might be there, it might be there. But we're not really being real precise, and we're not ever going to unless we really need to know exactly where those intercepts are. This locates the circle generally well enough, and we'll just kind of leave these finer details kind of fuzzy, and that's totally okay. Thank you very much.